Okay, question 13 is a circle theorem question. Sometimes good in any angle question either to add lines or remove lines. In this case, I'm trying to work out angle x. If I just forget about this line here for a second, what I've got is a cyclic quadrilateral. And what I know about a cyclic quadrilateral is opposite angles sum to 180. So I'll just draw my angle table first. Angle and reason. So angle ADC is equal to 180 minus 16, which is 64. Reason, opposite angles in a cyclic quadrilateral sum to 180 degrees. Okay, now I'm going to ignore these two lines over here and understand actually this is where I've got angle at the centre is twice the angle at the circumference. So angle A or X, or X, or A or C, sorry, X is 64 times 2, 128, and that's angles at the centre are twice the size of angles at the circumference. Okay, 128. 4 marks, 2 marks for getting these, 2 marks for your reasons. Okay, the nth term of quadratic sequence is n squared plus 3 minus 2. Find the fourth term of the sequence, so that means n is 4. So 4 squared plus 3 times 4 take away 2. If the first 5 terms are a different quadratic sequence, find the nth term. So if I work out my first difference, I've got 6, 10, 14, 18, so I'll go down another level. Because I've gone down a second level, I need to half my difference. So it's going to be 2n squared. Now the key to this is just remembering what n squared is. N squared is just your square numbers 1, 4, 9, 16, 25. So 2n squared is 2, 8, 18, 32, and 50. And you've got to talk about language. How do I get from 2n squared to my sequence up here? Well, I go subtract 1, subtract 1, subtract 1. So each time I'm just doing 2n squared and I'm taking away 1 from that to get my sequence. And the last question, you could do a probability truth for this, and I did think about it, but it's going to be quite a large one. If these are 10 coins in a bag, there are 3 £1 coins and 7 50p coins. She takes around the 3 coins from a bag, work out probability, she takes exactly £2.50. Well, to take £2.50 she needs £1, £1 and 50p. And there's 3 different ways to get that. She could get a pound, £1.50, so I'm just going to call I'll call it P, P, F, or she might get a pound and then a 50p and a pound, or she might start off with 50p, pound. I'm just going to work out the probability of these 3 and add them together. So probability of getting pound, 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 sorry, pound, pound 50. It's non-calculator this paper, so 1, that's 3 out of 10 times 2 out of 9, because I've chosen one of those pounds already, times 7 out of 8, which gives me 720, so 42 out of 720. Now you'll notice when I do these, we should get the same answer. So this time a pound, then a 50p and a pound. Well, that's 3 out of 10, times 7 out of 9, times 2 out of 8. And lastly, 50p, pound, pound, is 7 out of 10 times 3 out of 9 times 2. And if you notice, I could have simplified some of these fractions down, so a quarter or a third. I've not done that on purpose because I like my end numbers to have the same denominators. So actually I can say the probability of getting exact 2.50 is any of these three options. So if I add these together, 42 times 3 is 100, no it's not, yeah, 126. So my final answer is 126 out of 720. Okay, thank you.